few things to remember. Sine always has to fall between what values? -1 and 1. If we're talking about in a triangle, would we have negative sides if we're just, no. So in these types of problems, we'll have a number between 0 and 1. So if I ever say like sine of theta equals 2, I know that's not possible. In a triangle, the smallest angle has to be across from the smallest side. Okay, the biggest angle has to be across from the biggest side. And we know all the angles in a triangle add up to 180. So we are just going to jump right in with the problem. So solving the triangle, same thing as yesterday, but we are given different information. Okay, right now I have information about A and C. So if I'm going to use the law of sines, we would be doing A over sine A equals C over sine C. So A is 17.9. I don't know angle A. Side C, 13.2. Sine 75 degrees, 30 minutes. All right. So if I am going to plug this in, think of it as like you would have to cross multiply, right? So then if I'm going to find sine of A, I have to divide by the 13.2. Okay, so now let's plug this stuff in. So make sure you are in degree mode. And everybody remembers how to plug in like the 30 minutes. We had to on our homework last night, so hopefully that jogged your memory. 75 plus 30 divided by 60 in parentheses. And so when I do that, I get sine A equals 1.3129. Did everybody get that? Okay, what does that mean? Okay. I'm trying to say that whatever angle A is, its sine is equal to that number. Can sine be 1.3129? No. Sine can't be bigger than 1. So automatically I could just say no solution. There is no triangle where this would exist. Now, if you try doing it on your calculator, if you're looking for an angle, that's when we did the inverse. Remember doing that in the last sections? So if you do sine inverse, if you typed in second sine 1.3129, your calculator says domain error. So it tells you that's not possible. All right, so we might get cases where there isn't a triangle that works. All right. Let's look at another one. Angle A is 61.4 degrees. Side A, 35.5 centimeters. And side B, 39.2 centimeters. Okay. So which two ratios would I use here? So A is 35.5. The sine of 61.4. equals 39.2 over the sine of b. I need to solve for sine b. So it's kind of up to you how much work you need to show. I'm cross multiplying. You might be comfortable enough just plugging things in your calculator, but I'm going to write it out for the sake of our examples. Did you guys get sine of b to be 0.96949? Is that possible? Yes. Okay. Here's where the extra trick comes in today. So we saw a case where there's no triangles. In which quadrants is sine positive? 1 and 2. Okay. It's possible that there might be 2 triangles that work. 1 in each of those quadrants. So we are going to have to consider both possibilities here. So I know it could be quadrant 1 or 2. Reference angle. Okay, so to find that, what do we do? Sine inverse. So second sine 0.96949. And let's just go to 1 decimal place here. We'll keep it kind of simple. So we get okay. So now I'm going to look at my 2 triangles. Triangle 1, triangle 2. In triangle 1, my angle would just be my reference angle. How would you place 75.8 degrees in quadrant 2? So if you subtract those, you would get 104.2 degrees. All right. We had angle A originally. So now we should be able to find angle C for each of them. So we just have to subtract from 180. So in the first triangle, angle C would be 42.8. In the second triangle, it would be 14.4 degrees. It's possible that right here in the second triangle, you might get a negative for this angle, depending on what the others were. What would that mean if this angle turned out to be negative? It couldn't work, and you would just throw out that second triangle and you don't need to solve it anymore. Okay, so there may or may not be 2 triangles. All right, I have my angles. We had 2 sides already given. So what I need now is to find side C. To do that, we can do our law of sines again. C over side of C equals, we could really pick either. I'll just go with A over sine A. I now know side C. I now know angle C was 42.8. And the problem it gave me that side A was 35.5. And then angle A was 61.4. So this is like the problem from last night, right? thing I like to do at the end to kind of check. Your biggest angle and your biggest side have to match up. Okay, so from that, angle B was my biggest angle, was side B my biggest side in this? Side B was 39.2, so that worked out. Angle C was my smallest angle, so side C should be my smallest side. So I do that just as another quick check to make sure my triangle works. All right, now we have to do the same thing for our second triangle. So C over the sine of 14.4 degrees equals side A, 35.5, over the sine of angle A, 61.4 degrees. So we get 10.1 centimeters. Again, just a quick check. Angle B was my biggest angle. Was side B my biggest side? Yes. Angle C was my smallest angle, so side C should be my smallest side. What if they didn't match up like that? What would that mean? That triangle doesn't really work, and you would throw it out. Okay, so these problems are a little bit longer, because especially when we have to look at both triangles. Are there questions on that one? Okay. Let's look at another one. Okay. So we start, we have information about A and B. So A over sine A equals B over sine B. So cross multiply, show as much work as you need to here. I try to keep several decimal places at this step before I do the inverse, just to try to minimize my rounding error later on. Is it possible for sine A to be 0.71894? Yeah. If there is no triangle that exists, this is the step where you're going to find it, because you'll have something bigger than 1 right here. So we can find it. We know that sine is positive in both quadrants 1 and 2. So now we have to get our reference angle. How do we get the reference angle? Sine inverse. So I get 45.967. I'm just going to go ahead and round that up to 46. Because it would be 46.0 degrees if you rounded.
Is there always going to be two triangles with those?
Yes, because sine is positive in both quadrants 1 and 2, and that's 0 to 180, so it would work. Now, if we were using like cosine's positive in 1 and 4, but angle 4 is an angle, quadrant 4 is angles between 270 and 360, so then it wouldn't be possible. But just because of the fact that we're dealing with a sine, it is. Okay, so let's look at our triangles. If we have one triangle, that means in quadrant 1, angle A would just be the 46 degrees. Then angle, we didn't know C. So if we did 180 minus 46 minus 68.7, then that means the other angle will be 65.3 degrees in that triangle. Now for my second triangle, how do we find angle A? Because we have to put 46 degrees in quadrant 2, so 180 minus 46 gives me 134 degrees. So then when I go to find angle C, I do 180 minus 134 minus, what was angle B? And what happens? Get a negative. So what's that tell me? Not for this triangle. So now there is only one triangle that exists, only that quadrant 1. So we might have 0, 1, or 2 triangles as the solution in this case. Do you guys see why that triangle doesn't work? So now all that we have left to find is side C. So I'm going to do B over the sine of B, or wait, which side did I need? Yeah, side C. Okay, so side B, so 25.4. The sine angle B, 68. Equals, we don't know side C, sine 65.3 degrees. And I get that side C is 24.8 inches. Okay, if you want to kind of check yourself, angle A was the smallest angle, so side A has to be the smallest side. Angle B was the biggest angle, so side B has to be the biggest side. All right, what questions do you guys have so far? So we have basically looked at all 3 cases. Okay, I have more examples. We will do as many or as few as we need. We want to try another one? You guys are all just shaking your heads. No, please quit teaching. Okay. Why don't we try the homework?